All right, hello everyone. My name is Ty Everett. I'm the founding president of Project Babbage. This is a second video in the series. So if you haven't watched the first one, you should pull up the first Babbage tutorial, which is Hello World. And this time we're going to be starting off where we left in the last one with the app. So I'll tab over to my browser here, and we have the app that we built the first time where we click the button and we get the TX ID of the transaction, the action that we made. And what we're going to be doing today in Babbage tutorial number 2 is talking about action protocols. So the actual ways that we can build apps that are interactive, and actually we can, at the end of this tutorial, we're going to be able to see some messages on a global message board. You're going to learn about Bridgeport, which is a way for people to group together all of the actions that they've taken. And you're also going to learn about Parapet, which is a way for us to kind of talk to Bridgeport. So there is a blog post version of this tutorial available. I will link it in the video description on YouTube. So if you prefer to consume this content in written form rather than by watching a video, you can check out the blog post. I tried to go a little bit more in depth into certain things. And we will, without further ado, get started with making the changes that we're going to need to make. And I'll be kind of describing what's going on as we build the first interactive Babbage application that uses an action protocol. And that way we can have an interactive message board that people can post to by the end of this first little, the second tutorial, but kind of this hello world example for Project Babbage. So what we're going to do, we're going to start with the code we had before. If we go to app.js here, we see the code that we left off with. So if you haven't already, open up your text editor and pull up the code from last time. If you don't have it, you can pull it down from GitHub. So you could go to the first blog post or the first video and find the repository on GitHub and pull it down. Or you could just go back and follow the first tutorial and you end out with something close to what we have here. So this is the code from the last blog post. I have some comments here, and this is slightly different code than from the last video, but I'm just going to do what I did in the blog post, and that is to delete these comments. And that way we can kind of, these comments are useful for going through and understanding the create action stuff. But now that you understand that an action is just a thing that a user does in their application, and that applications need to take actions and group them together, we can get rid of some of these comments and make our code a little bit easier to kind of follow. So the first couple things I'm going to do are actually fairly cosmetic. What I'm going to do is I'm going to go to the CSS style sheet actually. So in the app.css style sheet, I think it's line 17, we're going to change the color of the background. So maybe it's not, wait. Yeah, so the background color here, I'm just going to change to a color I like a little bit more for our background, and then I'm going to delete this white background, or the white color for the text. So saving these changes, we can now see that our app looks a little bit different, and I think it looks a little bit better. So let's talk for a second here about this action in app.js. We have this action, and we're basically just, we're creating, so an action is the data that goes on the blockchain is an array of these string values that are in base 64, and we're actually converting them out of base 64 before we use them. But when we create an action, we specify an array of strings in base 64 format. What we're going to do is think about all of the actions that anybody can do, not only across your app, but across all apps ever. And if we just put data in wherever we want, if we just have whatever we think makes sense without really thinking about it too much, then all of these actions would actually start to run into each other a little bit. So for example, if I had an action with, we have the data from one app, the Hello World, right? But maybe we wanted to write another action for, we'll use the same example from the blog post, an electricity bill, right? So we have this action, which is, create my first action, but now we have another action for, paying, so send an electricity, we'll just say send a bill to Bob, right? So that's our power bill or something. All of the fields in this action are specific to this type of thing that we're dealing with, right? So, I'm not going to use the same exact numbers as the blog post, but we could say that the first thing is, I don't know, the amount of money that we want to charge Bob, and the second thing is how much electricity, so I don't know, 4,500 kilowatt hours, because Bob uses a lot of power. Maybe he's mining bitcoins or something, and that takes a lot of energy, so he's using actually 4.5 megawatts of power for $100. And then, the third thing could be like the address of Bitcoin, like the destination where he could pay all of his money to. So we could, come up with a Bitcoin address where he could pay. Now, all of these actions are great, and they can express correctly some of these concepts. However, if there is, one app for doing electricity bills and another app for sending messages, those actions would actually, it's going to get harder and harder to, know which actions are for which apps. And we need to actually think very carefully about how we shape things. We need to shape our actions, we need to mold them properly. And that way, every action is clear about what we're doing. Because when you create actions with apps, the apps need to clearly represent the intent of the user in what the user is doing, the action that the user is taking. So if the user is sending a message, that intention is different than when the user is sending an electricity bill. So if I'm a power company and I take the action of sending a bill to one of my customers, that's two different things. And so even if the data was exactly the same, maybe this was not an electricity bill anymore. So up here is never going to get on the blockchain. If I'm the recipient or the other party to an action, I'm never going to see this. This is just how I keep track of my, internally what the action was. So this description up here, we describe the action so that, the person who took it can see what it is, but not the person who is, receiving a message or receiving a power bill or receiving anything like that. So this field we can't really use to determine the intent of the user. We have to express the intent of the user in this data. And we can also use Bitcoin outputs as well, but that's beyond the scope really here. So for what we need to think about here, this data needs to adequately convey the intent of what it is that the user's doing. And so for that, we need to do a thing called have an actions protocol. We need to have a protocol or a system almost, a known scheme by which, an understanding about how the specific actions are interpreted in an application. And so we can't just put all of our information willy-nilly into this data and then hope that the recipient knows, oh, this is a power bill, just by looking at these three things. I'm not referring to that description up here, but if I got this, I'm looking at only these three things, and it's like, okay, $100 and 4,500 kilowatt hours, and then here's an address or some random thing, right? I'm not going to know this is a power bill. So we need to have specific protocols for specific things. And for that, what we can do to identify which protocol we're talking in, so how the data in the action is to be interpreted, in order to identify how the data in the action is being interpreted and how we should use it in our application, or even if it's relevant to our application, because of course a direct messaging app is not going to be concerned with electricity bills. What we need to do is have a prefix. So I'll go through the example I went through before in the blog post. Is why don't we just say that every action that starts with a posts protocol, right? And then we can say the sender. So we'll say maybe the sender is Ty, and then we can say the content, and or not. No, we say right. So we'll say hello. Basically, we could use the first field. So the first data field we can look at, and that way we know what protocol we're talking in. We know how the rest of the data in the action is to be interpreted by the person, the people who see it, the people who interact with it, right? So other apps, but also other users, and everybody else that deals with the data in question. So your company, if you're running a company that's dealing with user actions and how they're to be interpreted. So now, if I am just the recipient of one of these actions, I'm looking at this and I just I need to interpret and understand what it is to see if it's relevant to my application or not. I get these 3 fields and I say, okay, well, I'm going to look at the first one, and that's how I'm going to know what protocol it is. And if it's the right protocol, then I'll have an understanding about what it is, because I'll say, oh, the first one here is posts protocol, and I know what post protocol is because according to the post protocol, the second one is going to be the sender, and the third one is going to be what they said, right? So pretty simple. That's kind of what an actions protocol is. So an action protocol is just a way for us to be very clear about what actions are, which actions do what, and what the intent is, and whether the action is relevant to our application. So if I was running a direct messaging application or a forum, a web forum, maybe I would be concerned with the posts protocol, but I would not be concerned with the electricity bill protocol. So the instant I see, if I'm for any given action that I'm looking at, the first one, if it is not post protocol, so I'm going to look at this, oh, well, that's electricity bill protocol, so it's irrelevant to my application. I'm just going to ignore it because whatever this data is, whether it's anything that I don't know about, because I don't understand the electricity bill protocol, I don't have to be concerned with it. So this is this concept of action protocols, and that's what I want to get across at the beginning here, is we need to have, and I'm going to change this back to the post protocol just for a second. We need to have the first kind of field in an action, or it doesn't necessarily have to be the first field, but there has to be some way for us to know, based on the data, and based on the Bitcoin transaction that we're creating, that's dealing with this action, what the action is for and how it is to be used and interpreted. And that way, users, when they do things, no matter what application they're doing them in, the protocol they're using to create their actions is defined and it's unambiguous. And that way, everybody knows what the user has done, how to interpret it, and how to give them the experience that they expect. So that's the necessity for action protocols. Now, in the next little section here, we're going to implement this posts protocol. So let's start with this actions protocol. This action protocol, I say actions protocol, but it's really a protocol for creating actions. So I'll call it an action protocol. We are going to implement this action protocol for writing posts, right? So we're just going to leave the name here as Ty, and we want to have a little text field so that people can enter a text in our app. So we have this button in our app, right? But we also want to let the user type something. We're going to build this message board, right? And we're going to make it so that the user can post a message on the message board, and then everybody that speaks in this same protocol, any app, it doesn't matter if it's my app or your app or somebody else's, they're all going to know, oh, well, this is the posts protocol, and so all the data that's here is, I know how to interpret it. I know who the sender is, because that's always the second one according to the posts protocol. And I know what the message is, because that's always the third one according to the posts protocol. So the first thing we're going to do here is we're going to import React at the top. And we're also going to import a thing called useState. So useState is a hook in React. So and I'm assuming a little bit of knowledge about React here. React is a framework for creating, user interfaces. It is not required that you use React. You do not have to use React to create Babbage apps or Bitcoin-powered apps. React is just a convention and a thing that I know, that I'm familiar with, and so I'm creating this tutorial using React. But you don't need to use React. You can use JavaScript, you can use jQuery, you can use just Angular or Vue or PHP, with any of these other kind of web technologies that exist. It's possible to use the Babbage desktop the Babbage SDK. It's possible to use the Babbage SDK using any of these technologies. It's just that JavaScript and React is kind of my preferred little stack or suite of tools that I use. And so to address the questions there, we don't necessarily need to use React in order to work with Project Babbage. So we've imported useState, and state is just a way of tracking things that happen in React. It's a very high level thing. So we're just going to have a variable. It's almost like a variable in JavaScript. We're going to call our thing post set post. We'll call it post text. Set post text, and this is useState of nothing or no text. So we're saying here is our variable. Here's the function that we're going to call that would update our variable. So we're not going to just say, post text equals something, because that's not how React works. You have to use the setter. So you can set post text whenever it changes. And then we're saying the default value is this null, this nothing. And the other thing we're going to do here, just moving along, is we're going to import the text field from Material UI. And one of the reasons why I used Material UI for this tutorial is because we can do things like this. Text field, and we want it to be, okay, so the first thing we're going to say is that the value of the text field is going to be that variable that we just worked with. So value equals post text. We're going to say on change, and we're going to say the E is taken as the first parameter to an arrow function, and we're going to set post text the e.target.value. So that's basically just saying that whenever the text field changes, we're going to take whatever the value of the target element, which is the text field. Whenever a text field changes, then we're going to set the post text to be the value that is in the text field. And then it's going to change, and the value here is going to update with the new value. So that's basically how you do on change and update a state variable in React. In a very kind of brief sense, just trying to get you to understand what you need to understand in order to build kind of this example. But by all means, use your preferred framework. If you're already a developer and you understand this stuff, the package is just on npm. So we're going to say that this is a multi-line text field, and we're going to say that the rows, it's going to be like 4 rows, and we're going to say the placeholder equals enter some text, right? And we're going to come down here, and because we're building a message board, I'm going to change this to send. So we're no longer saying create action, we're saying send. And the final thing we're going to do here for this posts protocol is we're going to actually say post text. So that way, the third element, when we call create action, so when we click this button, right, we have this button that says on click, we call the handle click function. So the user types their text, it updates the post text state variable using the state. And then when we click the button, it's then going to come up here, and this function is going to run. And this here is going to be the latest version of the kind of the state variable. So that way the third element, like we said, in the post protocol is going to be the message to send. And so this would work, right? So we'll save and I think we also want to add just a little space. So I'm going to do BR, and then another one just to add some space. And you know, my styling isn't really the focus here. Now we've got a text field. We can type something in here. So this is a test, right? And if we click send, we are creating an action again. And one other thing, I'm going to cancel this. I'm going to cancel this because I don't, and it's going to throw an error. That's okay. If you cancel an action and it throws an error, it's just saying, you know, basically that the user called create action and the user denied the request. So that's okay because it's an error. You can have try, catch, you know, do your error handling, but this is a basic application. We don't necessarily need to do that. The reason why I canceled this is because I forgot to update my action label or description. We don't necessarily want to call this send a bill to Bob. That would be kind of confusing. This is going to be send a post with posts protocol. So this is the posts protocol. This protocol is not actually, so I'm going to send the post. We're going to do this. We're going to create an action, right? We'll allow it. So 101 Satoshis there. It can sometimes be a little more, but we'll get the TXID, right? Now I've created this transaction, right? However, this posts protocol does not necessarily, and then what we're also going to do is we're going to come over here and we're going to say, you know, we're going to clear out. So we're going to say set post text back. So after the action is created, the text field is cleared. And that way, you know, if we did this again, it would clear it out and put it back to how it should, you know, after the user hits send, the action gets sent out and then, you know, it clears it so they can write another message if they want. That's kind of our first little stage here. So this is action protocols, conceptually speaking. We have a clearly defined protocol, and it's how a user can write a message and have it be sent. You're probably still wondering, how the heck do I get these actions and actually put them into my application? How do I show the user these things that we want to create? You know, we get this TXID put on the screen in the alert, but that's not very helpful, is it? We actually want to put the actions that people have taken on the screen. Not only me as a user, but everybody who's followed this protocol. We want a global message board that anybody can post a message to. And we don't have that. We have this actions protocol, that's great, but it doesn't solve our problem. The next section here is that we're going to take our actions protocol for writing a post. And we need to make some changes. And let me tell you why. The posts protocol, unfortunately, is flawed a little bit. The posts protocol does not respect, I mean, you know, if my name is Ty and I write a text and it goes on the posts protocol, somebody else could, you know, say their name is Ty too and write something on my behalf. And nobody could know which one is the real Ty. Nobody could know who is who and actually be able to, you know, make sure I'm not forging somebody else's, make sure that I'm not like forging another person's name or something. We want to have attribution to like have an author that wrote something, and we don't want to be able to like prevent them from having identity in our system. We want to make sure that people can have identity and be attributed for what they write. So that's one flaw with this protocol, and that's one of the reasons this is, this is flawed. What we're going to talk about now is how to improve this. So a couple of improvements need to be made to the posts protocol before we can actually use it. It is an actions protocol. You know, we are clearly defining. It's just it's a poorly designed one at the moment. We are clearly defining what it is. So the posts protocol. And we are clearly defining the second one is going to be the sender and the third one is going to be the content, right? So that's clearly defined. That's great. That part is good. We're actually, we're being clear about what we want to do. And we're saying that when the first part is post protocol, that's kind of what the second and third one means. So when the first one is post protocol, second is sender, third is content. However, the other flaw, aside from this forgery problem we're talking about, where the second field could just be anything and we just trust that somebody's not going to use the wrong name or something, is this. The second problem is that posts protocol in the first field, right? We're saying this in anybody that uses posts protocol, in their first field is in compliance here, except, I don't know, maybe there's like a post office or some other, a post-it note protocol, some other thing, and they're also using the name post protocol. What I'm saying is this is not quite specific enough for our needs. We need to make something more specific so that there's no way in the universe that somebody's going to be able to sort of guess what they're not going to accidentally, use the same name as me. We need to have something so unique that it's not possible, or it's not feasible to make actions that accidentally, are different. And that way we know we have our own little space that we can use for our protocol. So we need to have a really unique, thing that I just, hit my keyboard. Nobody else is going to have. And the way that we've done that is there is another protocol out there. And the protocol that I'm going to talk about next is the Hello World protocol. And that Hello World protocol actually has fixed both of these problems. So what I'm going to do is I'm going to pull up the protocol specification I linked in the blog post. So I'm just going to go over to the website here, and we're going to go to the Hello World protocol homepage. This here is the Hello World protocol. And this is a real protocol. So that post protocol, I must say, was just, it was fake. It was not actually a real protocol that you can use it. We just did use it, but you shouldn't use it because there's some problems. I was just trying to get you to understand conceptually about action protocols and specificity, making sure that things are in the right order, all that stuff. So it served its purpose, but now we're going to actually talk about a real protocol that you can actually use. And by the end of this video, you will be able to use this protocol to create, this global message board we've been talking about. So Hello World protocol is defined here. I'll leave a link to the protocol specification, which is the actual rules defining how we create, these Bitcoin transactions or actions that comply with the Hello World protocol. But the first thing we're going to do to solve the specificity problem is the Hello World protocol basically just comes out and says, here's this random string of numbers and letters that I came up with, which is actually a Bitcoin address, but that's a topic for future videos. Here's this string of random, or not random, but here's this very specific string of letters and numbers that nobody else is going to guess like by chance. They're not going to just say, oh, you know what, I'm just going to decide that by chance I want to send my actions using the first element 1HE11OMZ capital Q S capital A. Nobody's just going to guess this by chance and accidentally kind of step into our namespace. That way we can be sure that maybe somebody's going to deliberately do it, or maybe they made a mistake. And in that case we can just ignore them, but nobody's going to use it for anything aside from this, right? So this is our Hello World protocol, and it just comes out and says, this is the first field. By decree of this being the protocol, if you're going to follow the Hello World protocol, this is going to be your first data element in your action. Very simple. That solves the specificity problem. That's the first problem solved, right? So we talked about maybe someone could use the post protocol namespace how it was before and accidentally do that. But now with the Hello World protocol, that's actually solved. The second thing is a little bit more tricky. So we have this name, and it can be forged. There's a thing in Bitcoin called digital signatures, and you can actually create a signature from a key. We're talking about keys as being this kind of, it's just what it sounds like. It's a thing that a user has that only they can use to kind of unlock or access their information. So users have these things called keys. They have the primary key, they have the primary signing key, they have the privileged key. They have all of these keys that we can use, and then they have paths or children of their keys. So the path of 1033/1 or 1033/10, or maybe it could be 1 or 11 slash 3 slash, whatever, right? So 11.3.41. Any of these keys, and I'm going to switch this back to be 1033 slash, 1033 slash 10. We're talking about keys, and keys are things that only users have. So opening my Babbage desktop software here, I am this user. I'm logged into Babbage desktop, right? So I could go to settings, I could see what my identity is, but this is me as a user, and I'm logged into Babbage desktop. I have my keys and nobody else has my keys. That's the cool thing about this. So these users have these keys, and these keys can create things called signatures. So you might have already thought of what I'm about to say, but why don't we just take a signature that only the user can create and attribute that to their identity? And that way we don't have these forgery problems. And the way that we're going to do that is we need to install a couple of different pieces of, we need to make a couple of changes to the code. And after I've made these changes, I'm going to go into a little bit more detail about how we've solved the problem with creating these digital signatures and such. The first thing I'm going to do is I'm going to go to another terminal in my code, and I'm going to say npm install bsv at _1.5.5. I'm installing using npm, so this is just an npm command. It's installing a specific version, and you can get this command from the blog post, or you can copy it from here. But it's just a specific version of a library, a tool, just like Babbage SDK or Material UI. So now we can import this new tool into our BSV. From BSV. So BSV is Bitcoin SV. It is a version of Bitcoin that we're using to run all of this stuff. And what we're doing here is we're importing this kind of library or set of tools to interact with Bitcoin SV. And while we're importing things, we're also going to import another function from the Babbage SDK, allowing us to do this whole idea of signing, this digital signature. So that way we can solve this forgery problem. So that is get primary signing pub. So we are using a public key, which is a type of encryption key, and we are retrieving it here. And that way we can use it to make a signature. And the signature is going to, so we're going to say const public key is await get primary signing pub, and we're going to say path of, and the same path, so m/1033/10. So the same path as you have down here in create action. And we're using this key as the way that we're going to identify the user. So this key is kind of so we have the public key, which can be public, and then the user has the private key, which can create the signature that only they can create. So the public key is going to be the identity almost in here. And we actually need to convert this into the right format of key, and you may not understand this fully. So if I'm going a little bit above your head here with some of this stuff, don't worry, because we're going to cover a lot more in future videos and tutorials. But basically what this allows you to do to get your app working so that we can have, this hello world protocol, and we can have these users that are talking to one another, is we can say the sender ID, which is going to be the ID of the sender. We're going to say bsv.address from public key, right? So we're saying take the address from a public key, and then we're going to say bsv HD public key from string public key. And then we're going to convert the address to a string. So what this is going to do, if I've written this code here correctly, is it's going to take the public key, which is the way that we're going to identify the user, and we're going to convert this into a different format that is better. And it's actually the format complying with the hello world protocol. So for the second field here, it's going to be the sender ID. So hello world protocol, sender ID, And this part here is actually fine, so no more changes. That's it. We should actually now be able to create transactions or actions using this create action function that comply with the Hello World protocol. So Hello World protocol, HWP for short, HWP. So we're going to send a post with HWP, or we can say Hello World protocol. So we'll update our action description there so that we know what we're doing in our UI and Babbage desktop. We're going to save our changes. The code compiles, it's green still. And now we have our sender ID. So the sender ID is and we're actually going to log to the console, right? So we'll say console.log, and we're going to say sender ID. So the ID of the person who sends this action. So let's look at the field, the push, these are things called push data. This is part of the protocol specification, and I'm not expecting you to understand any of this yet. But what I am going to just say here is that the sender ID, and I quoted this in the blog post, specifically just this part, sender ID, which is a Bitcoin, a base 58 encoded BSV address whose private key signed, using a digital signature, signed at least one of the inputs to the HWP or Hello World protocol action. So when we tell Babbage SDK, when we tell this Babbage SDK up here at the top to create an action, and we give it the key name and the key path, we're actually telling it to use the same key to sign the Bitcoin transaction, and we're also using the same key up here when we are getting primary signing pub. So the key is primary signing for signing it, and the primary signing pub with the same path. So 1033, m/1033 is the open path, and then we're using number 10, so just the 10th kind of child in this key path. And again, key paths and key names and signing, all this is going to be covered in more detail in future videos. But we're getting the key, we're converting it to the right format, and then we're using the same key to sign. And then for this sender ID, instead of putting our name or something, we're putting this key that only the user has, so that we can verify the signature was created by this same person, and that solves the forgery problem. So there were two problems originally with our original posts protocol. Number one, it wasn't quite, someone could maybe accidentally use the same name. And number two, or no, not the same name, the same protocol prefix to identify their protocol, and they could talk over each other. And the second thing was that forgery problem where anybody could just pretend to be me. But I'm the only one that has this key that can sign this. So we're putting it here as the sender, and anybody who tries to use it, somebody tries to use my key here, if they don't actually create the right signature, which only I can create, then, it would be ignored. And so we're ignoring all transactions. So we're saying any Bitcoin SV transaction where the first output, you don't have to understand any of this, but it complies with the Hello World protocol, provided that a private key belonging to the address from, this field here, signed at least one of the inputs. And that means that it's signed on the action. And if it's not, and what that means, what that sentence just says is it's actually invalid and we're going to ignore it. So nobody can create HWP Hello World protocol messages unless they have the correct signature from the key. And it's the digital signature that belongs to the user. So we're going to save this now. And let's actually see this work, right? So we're going to create one more action. And still, we're not going to see anything in our app. But we're just going to say, I don't know, we'll say, hello from the video. And you may actually see this in your application later because we're now complying with the Hello World protocol. We just clicked the button there, I do believe. Did I click it? We'll click the button. We did get an error. So, derivation path must begin with m/. Did I make a typo? So this is just telling me that I made a typo. m/1033/0 or /10. You may have already seen this in in the video, and you're probably like thinking to yourself, well, that guy made a typo. It needs to be the same as here. So yes, that was just a typo. We'll save this, and we're going to see if this wants to work now. So I'm going to refresh the page just to be safe. And we're going to say hello from the video. And we'll click send. We're getting another error. So this is just debugging. Address must be an instance of public key. My bad. So I have the code in the blog post. If you want to copy the code from there, I just forgot to add a .public key to that. And hopefully this gets less confusing over time as you kind of get familiar and learn how to create these things. And I'm also going to work on making the software better over time as well. So anything you find confusing, please let me know, and I will certainly do my best to address the problems. And my goal is to make building Bitcoin-powered apps as simple as possible for everybody. So I'm going to try again. Hello from the video. We're going to say send. And this time we're getting a request. So we'll go ahead and authorize this action to be created. And we'll see the TXID here. And now we are officially actually complying. You know, this is another milestone. This is another thing we can think that we've achieved because we're actually now creating transactions that comply with this protocol. And that way, every Babbage app, you know, any app that says they want to speak the Hello World protocol can understand this. So that protocol is now used by our app. We now support this protocol. And so that is the kind of the first part here. We're now to a point where we can write a message, put it on the blockchain, and have the blockchain recognize it as being compliant to the Hello World protocol. And we also see that this is the thing. I should have logged sender ID with it as well, but this up here, this 14B2P, etc., that is my sender ID. That is the ID of my sending key, and we're gonna log here. You know, we'll say, I don't know, sender ID, right? And then that way next time we'll actually see the sender ID. So we are now creating transactions that comply with this protocol. We are writing the data to the blockchain in an action. And again, like I said before, at the end of the last section, you're probably thinking, yeah, this is great, but how do I see all of these actions in my app? Before there were problems with the protocol, so we couldn't make it work. But now we're actually to the point where we can start showing you how to pull all of these actions into your app and how to make it work the way that it needs to work. For that, we're going to need to use a thing called Bridgeport and Parapet. But let me talk about Bridgeport a little bit before we kind of make it work and install the software and write the code. So Bridgeport is basically, we have these action protocols we've talked about, right? So the action protocol we're working with here is HWP, or the Hello World protocol. So from now on, I'm just going to say HWP because it's I don't know if it's less syllables, but it's shorter. So we have the HWP protocol, and what Bridgeport does is it takes all of the actions that users have done, that all users have done, that comply with a certain protocol, you know, a subset of the blockchain. It's like a subnode. Every blockchain. Sorry, I kind of went off on a little tangent there. Bridgeport is a system for tracking the actions taken by users under specific protocol. And each protocol gets its own bridge. So the Hello World protocol, HWP, gets its own Bridgeport bridge. And that bridge is just a database that people can use to ask Bridgeport to give them all of the actions that were made under that protocol, or even to write more advanced queries such as, you know, only give me the actions that I sent, that were my sender ID, but that's more advanced. We're not going to do that in this video, but you can write queries against these Bridgeport bridges that ask Bridgeport to give me, you know, from the HWP bridge, which is a bridge specifically for Hello World protocol, all of the actions that people take using Hello World protocol are going to be part of the Hello World, the HWP bridge on Bridgeport. So each each Bridgeport kind of action database or little group of actions under a specific protocol is called a bridge. Each bridge gets its own bridge ID. So the HWP bridge is on Bridgeport. Let's go find it. So I run a website that hosts a Bridgeport node, or just a little server that runs Bridgeport. So I'll go to Bridgeport, and anybody could run actually a Bridgeport node and host the kind of bridges that they want, but that's a whole other topic for a separate series of videos, let alone what we're talking about here. So at the bottom here, these are all of the bridges that I host on my Bridgeport node. And Hello World protocol is one of the bridges. So this is the bridge ID that's specific for Hello World protocol. So anybody that has a Bridgeport node, and actually that's kind of, again, I'm going on tangents here, but this is the Bridgeport bridge ID for the Bridgeport bridge of HWP. And we can basically use this to, when we talk to Bridgeport, we can say, here's my bridge. I just pointed at my screen. I'm not going crazy, guys. I've been writing a lot of code recently, but I'm not going crazy. I don't think. We can ask Bridgeport for the specific transactions we want by using this bridge ID, which is specific to the Hello World protocol. Now, in order to make this work, we need to talk to Bridgeport. And in order to talk to Bridgeport, we need a piece of software that is designed for that purpose called Parapet. So Parapet is a piece of software that we can use given, we give it the bridge ID, and then it goes finds a Bridgeport node like mine, for example, because I think I'm the only Bridgeport node right now, unless this is the future, in which case I'd be very glad if there's, other people running Bridgeport nodes. We're going to install into our project Parapit.js. And Parapit.js is, I just described kind of, it's a way of talking to Bridgeport. Now we're going to start making some changes, and what we're going to do, our goal, we're going to ask the HWP bridge for the last 10 actions that were Hello World messages, that were HWP messages. So we're just going to go and talk to Bridgeport and say, give me the last 10 messages that were sent using HWP, the Hello World protocol. And that's how we're going to build this interactivity. So the first thing is we're going to change our import. We're going to use, instead of just using useState, now we're also going to use useEffect from React. Finally, we're going to import Parapet from, Parapit.js. And that way we can use it inside of our project. So we're going to add a useEffect to our React component. This is just a hook. And basically, if you don't know what useEffect is, you should definitely look it up, because I'm not kind of, this is React specific. It doesn't have anything to do with Bitcoin. It doesn't have anything to do with actions or Project Babbage. It's just specific to React. So there's a useEffect, and in here we're going to put an asynchronous function. So that way you can use await. So just like we did before, except for now it's inside of a thing, and we're calling it immediately. So it's called an immediate function, or IIFE, whatever you want to call it. Basically just a way for us to be able to use await. So we're going to say result equals, actually no, let's make our state variable first. So before we do any of that, we need a place to put all of the messages that we're going to pull in to our app from Bridgeport using Parapet. We're going to use Parapet to pull in the messages from the HWP bridge on Bridgeport so that we can show them to the user and read the data from the blockchain in order to get a good experience for them. So for that, we need to have a messages variable. Messages, and again, set messages, because this is React, and it's equals use state, and it's just going to be an empty array at the beginning. So there's no messages at the beginning, right? So what we're going to do is we're going to say the result is await Parapet. Parapet wants a couple things. If I So it's saying here, if you look, I don't know if your text editor supports this, but it wants a bridge and it wants a request, right? And we can pass in some other things, but we're just going to pass in a bridge and a request. So first up, the bridge is pretty simple, right? So we want to use the bridge ID of the bridge. So this is not the same as the protocol namespace for HWP. It's actually the bridge ID for where we can, reference the Bridgeport Bridge that holds HWP transactions. And that is that string. And I copied that from right here. So if you go on Bridgeport, any of these protocols, which if you want to use these other protocols and read them and understand them, I would be happy. I would be very glad if you did that and asked me questions about them and said, hey, I'm trying to build a thing that uses the Bridgeport host resolution protocol or some of these other things. But again, I digress, and I'm trying to stay on topic here. So the HWP bridge has this bridge ID, which I found on Bridgeport. So that's our bridge ID, and then the next thing is request, and we are making a request from this bridge. The type of request we're making, and if you want to know more about this, you should definitely read the documentation for how to use Parapet, which is it's on GitHub. I'll link it in the description, and I'll also link it. It's linked in the blog post as well, but we're making a JSON query, and the JSON query is the type of request, and then the actual query, this is just something that you do. It's the reason for it is complicated, and we will get into all of this stuff in other series, in other videos. So if you want to learn about this, there's going to be, documentation, but there's also going to be blog posts, other tutorials. So we're basically writing a query that says find anything and give me the first 10. So we're saying from the Bridgeport Bridge that holds all of the HWP messages, run a JSON query. And this is kind of like BitQuery, if you know what that is. But we're basically just saying let the result equal, this whole thing that we've just done in Parapet. If I were to translate this into English, it would say something like, from the HWP bridge, run a query that gives me the first 10 actions. That's all you need to know about that. In the future, I will show you how to use this in more detail, and how to write effective, action queries against these Bridgeport bridges. But for now, we're just going to say set messages, and we're going to set the result. So now, this use effect in React is going to run whenever the page loads, and it's going to set. At the end, it's going to set, once we get the response back from Bridgeport, all of those messages are going to be put into this messages variable. So in order to show these on the screen, we're going to come down here, and we're just going to say more BR tags, and we're going to say messages.map, MSG, MSG, and I, and we're just going to render out onto the screen. So we're basically saying for every element, it's like a for loop almost, for every element, for everything that's in that messages array, we need to put a div, or typography, and paragraph, so it looks nice. We'll close our typography tag, and inside of it, and we're going to say key equals I, right? I don't know if this is exactly how it is in the blog post, but the code from the GitHub that you're going to see for this is going to be the code from the blog post and not the code from the video. So if it's slightly different on GitHub, then that's going to be why. So msg.message, which is the actual thing. So if we look at the HWP documentation, we can see that the documents have sender, ID, and message. So msg.message is going to be the content of the document. And we're also going to add B, so just bold, right? And at the beginning, we're going to give the sender. So msg.sender. What this does is it basically says, go through all of the elements in that messages array and then put them on the screen as typographies. I don't know if typography is actually defined, so I'm going to come up here and I'm going to import it from Material UI. And now we're coming over here again, and we're going to save this. And we're going to see, yep, now it's all green. We're going to look at our app, and we're going to see if this worked. Oops, we're getting an error. Messages.map is not a function. So hang on a second here. I think I have to, oh, I'm sorry. Another thing we need to do is there's a hello collection. So we need to say from the collection, which is a subset of the posts, or a subset of the Bridge database. Now it works. And that's exactly the code that's on the blog as well. So what we're seeing here is actually a list of, we're seeing a list of all of the actions that people have taken using the Hello World protocol before. So what I want to see, if you follow this tutorial, is I want to pull up my Babbage app and I want to see different senders sending, you know, these are all me, the 1A, this address here is me. I want to see other people. So not just me talking in this message board. And I think we're going to get there. So if you follow this tutorial to this point, now you're actually reading data into your application. You can build interactive things that are based on action protocols. You can render this data into a good user experience for your users. If you have a better way of styling this than me, if you want to try to make a better version, you definitely should. And you can follow the other tutorials as well. But now we have these actions rendered out for the user. You're using Parapet to pull the actions out of a Bridgeport Bridge, which is just a set of transactions that are of a specific type or group. And that's exactly how this is. That's exactly how we build, applications with Project Babbage. So now let's create another action, right? So we're going to say creating another action in the tutorial video, right? So we'll click send. We will authorize the action that we're just taking. And it's not going to show up, We see this TXID still, and that's kind of, it doesn't look the best, so we're going to get rid of that. But our action isn't showing up. And that's because we didn't incorporate a live socket. It's not real time. If we refresh the page, then maybe it'll show up. But we want things to show up immediately in the ideal case. So I'm going to refresh the page, and it's going to show up. Creating another action yes, so here it is. But the last thing we're going to do in this video is first, we're going to get rid of this whole TXID thing in the alert. So we don't need to see this every time anymore. We're going to create the action and it's just going to show up. It's going to be a live socket. Second thing I'm going to do is I'm just going to copy this use effect here and I'm going to make another one. And I'm going to kind of let you surmise for yourself what this is doing. It is fairly similar to the other one, but the first thing we're going to do in this copied use effect is socket. We're going to use the same bridge. We're just going to change this, and you can read the documentation for kind of the sockets stuff with Bridgeport. How do you actually subscribe to a socket? That's part of the Parapit documentation, and like I said, I want you to go through and read these docs and figure out how to use these tools to create things with Project Babbage. I will be creating tutorials, but if you want to learn how to do this stuff before the tutorials come out, then I want you to read the documentation and actually ask me questions. Send me a message on Slack or on in the YouTube comments or anything like that, or send me an email, and I will be happy to answer the questions. But read the docs, understand this stuff, and go from there. So what we're doing to make the socket work is we're saying this is now let socket equals Parapet. We're saying the type is no longer a JSON query. We dropped a lot of those other limits out of the socket query. And we're going to say socket.onMessage equals, we'll say this is an event. I think it's E actually. We'll say this is an asynchronous. Do we want an async? E. So we're going to say what we want to do is data equals JSON parse E dot data. So we're going to say event data. We're taking the data from the socket. We are going to say if event data dot type is not message, then we don't want to use it. And then otherwise, we're going to say set messages. And what we're going to do is we're going to take old messages and transform it using an arrow function into first up old messages on the bottom of the array, and the top is going to be event data, which is going to be the actual message event containing the thing. So if I did this properly, and we'll see if I did or not, what we're doing is we're taking the data from the socket. I'll kind of summarize this a little bit. So we're making a socket, and we're saying, we're telling Parapet to listen on Bridgeport for whenever any new messages whenever new HWP messages come into the bridge, to let us know. And then we're saying whenever that happens, take the data out, parse it, make sure it's the right type. If it's not the right type, then do nothing. And then if it is the right type, we're going to update the messages array. So again, this array up here, which contains all of the messages that we're showing on the screen. On top of the array, we're going to put the data from the new message that just came in through the socket live. And then we're also going to, include the old messages that were already there. So high level summary of that. Let's see if it works. I think it might, but let's see, because I just kind of coded that live okay. So first up, we see the existing messages. We're going to say testing live sockets from the video. And I will send this action. There should not be a TXID alert at the top anymore because we've gotten rid of that. We logged to the console that the sender ID is this. That's what we calculated before. And if we come over here, we do not see it. Oh wait, is it at the top? Ah, yes. So we said that we wanted it to be at the top. So the live socket came in, and actually we created the action by writing data using the create action function in the Babbage SDK, using the handle click, right, in the button. So we came over here and we actually wrote to the blockchain. Then that data got picked up by a Bridgeport Bridge. Because it was complying with the protocol, it wouldn't work because the Bridgeport Bridge is only concerned about HWP messages that are valid. So if we did something wrong, it wouldn't have worked. Then we got notified about it live. So now we have our application. This concludes the kind of coding portion of this tutorial. We now have an application, a global message board, where anybody can post messages using this Bridgeport Bridge system, using action-oriented programming. So apps in Babbage have two mandates. The first is that people need to create actions, and then the apps need to take the intent of the user as they create their actions and clearly convey that using an action protocol. The second thing is that the apps, so that's kind of the writing, writing data to the blockchain using the create actions function. So that's the writing portion of what apps do. The reading portion of what apps do is the second thing is take all of the actions that are relevant, whether or not they were created with your app, and give them, feed them in, as long as they comply with the right, the action protocol. Feed them in and use them to build a good user experience. Because when people have good user experiences, they come back. And you can take commissions. So we have these actions that cost a little bit of money. And I talked about this in Babbage Explained. In fact, I'm just going to refer you, if you want to learn more about how Babbage works on a conceptual level, not as a programming tutorial for developers, but as a kind of describing the economics of it and why people should do things like this, check out the Babbage Explained video series as well, because that's a very important and I mean, it's just explaining why we do this stuff and what the incentives are. So go check that out if you want to learn that. But I won't repeat myself very much. So I think that's the end of this tutorial here. Congratulations if you followed it all the way through. There's going to be other tutorials coming out, and you can read the documentation. You can take this. I will point you to Convo Messenger. So if I go to convo.babbage.systems, this is a more advanced Babbage app. I built this as a demo. This is completely open source. You can see this is a private messaging app with pictures and eventually video, secure with the privileged key with having the user enter their password. This is a fully on-chain, using Bitcoin SV, encrypted messaging app that you can actually use. And not only that, but it's open source. You can look at my code. How do you do pictures? I'm going to cover that in another tutorial. How do you upload files without paying, miners on Bitcoin tons of money to put the files on the blockchain, but the transactions, the actions that you make can contain and reference multimedia content, audio, streaming video, video conferencing, groups, encryption, all of this stuff is possible. So I'm done rambling. Check out Convo. I will leave a link to the GitHub repository where there is the Convo code. And I will be improving that, making it easier to follow, everything like that as I have the time, as I'm creating all of these stuff. That is the Hello World example with the HWP protocol. You learned about, incorporating all of these things into a working Babbage app. So thank you for watching. I'm going to end it here. My name is Ty Everett. I'm the founding president of Project Babbage. Let me know if you have any questions, or if you want to build something really cool and you have this idea for a Bitcoin app. I will show you literally how to do it with Project Babbage, because anything that you can do with Bitcoin, you can do better with Babbage. And the reason why is because users own their identities and they control their data because of their actions. And so that's it for me. Thank you for watching. I hope to see you. I hope to hear from you. I hope you build really cool things. So thank you for watching.